NBA pod, but it's just Papa John. I'm gonna talk about my FE mechanical exam. I took the FE mechanical May 10th. I think got the result about a week later. And I passed the FE mechanical. It was my first time taking it, and I'm gonna just keep the beginning brief because I know a lot of y'all don't have a lot of time. I'm gonna just keep the beginning brief about what I did, how I passed. So, I used Prep FE. I used Prep FE for about a month. Um, and I took the exam like a couple. I graduated on the 13th. I took the exam on the 10th. So I was already done with finals. So I took like Friday, Saturday, Sunday, Monday before my exam. I studied those 4 days on like Prep FE and using a practice exam for about, I don't know. It felt like maybe 12 hours a day, but it was probably about 8. I didn't study on Monday, the day before my exam, but I studied Friday, Saturday, Sunday for about 8 to 12 hours a day using Prep FE and the practice exam. I did Prep FE for about a month. I got the practice exam and I used the equation sheet. I think I used the TI-83 Solar calculator, and that was just what I did. If I was going to suggest anything, just to keep it brief of what you should do, I think you should get Prep FE use it for about a month. Prep FE is really good because it offers you, a good way to navigate the equation sheet. It's really good for the electrical engineering questions, the statics, strengths of materials, the questions that are in multiple different categories. It gives you really good background on like the heat transfer, the material processing, the dynamics and kinematics of machinery. Those aren't the best questions. Those are kind of basic as compared to probably what you'll see on the FE, but it's really good for like the electricity, magnetism, mathematics, and things of that nature. It's really good for those questions. And then definitely get a practice exam. Um, Go through the practice exam at least once. What I did is you get like about 3 minutes per question on the FE. So I tried to do the first 50 questions in 150 minutes, and the second 50 questions in 150 minutes, and I took like a 4 hour break between. I know you don't get a 4 hour break on the exam, but that's just what I did to practice. And I did decently enough that I felt like I could take the exam. Practice exam is really good because it gives you a good feel about what you'll see on the exam and just like some good questions and to prepare you for the format of the exam. That's all for the beginning portion. I'll go a little bit more in depth, but if you just wanted a quick in and out, you're about to take the exam, or you just want to know what to do, I suggest doing Prep FE, getting one practice exam, Prep FE for about a month, practice exam for um, just do one practice exam and you'll be fine. I think if you can get at least 60% on the practice exam, you're in great standing. 55%, you're decent. 50%, that's like barely passing. But make sure to use the equation sheet. If you can navigate the equation sheet, Prep FE, you'll be all fine. Now, to get a little bit more in depth, I'm going to try to leave time cards for the people that are going to say that for the in depth portion. You can definitely put this on 1.5 or 2x speed because I'm a little bit long winded, but a personal background to see if this is more applicable to you. So, I'm a mechanical aerospace engineer. I graduated from an SEC school. I was like a decent student. Like, my core MAE classes, I did better in like a 3.7, 3.5 GPA. I don't remember off the top of my head. I think at one point it was 3.7, but I think over like my senior year when I already had my job secured, I was like, I don't care. I had my job secured at the beginning of my senior year, and once I knew I graduated, I tried in heat transfer and then thermal fluids lab because those are my core classes, but the my electives where I didn't really care as much anymore. Um, I did some research. I've co-authored 2 papers, but overall, I'm only an average student. So I think anybody could pass the FE. It's not really too crazy difficult as long as you do decent studying. So the best way I learned how to study is I learned best by doing practice problems and remembering solutions. So it was good for the FE for me to just do a lot of practice problems until I saw all that I felt like I could see. Because when you do prep FE, you'll do your thermodynamics, and that has pretty good thermodynamics questions. But I was doing my dynamics and kinematics questions, and eventually the dynamics questions get recycled and you start seeing the same stuff over and over and over again. And when you start seeing the same stuff, I'm like, okay. I go to the exam booklet. I'm like, okay. I'm only seeing the same stuff over and over again. It's only going to get so good. Like my mechanical design and analysis, when I do that on Prep FE, you see the same couple questions. Measurements, instrumentation, and controls. You start to practice, you see the same couple questions. So when you get a good background, you know, that's all you need. That's all I tried to do. Is I just tried to get a good background. I knew, based on my coursework and my course history, what I'd be good at and what I'd be bad at. I knew that I wouldn't be too good at mechanical design and analysis. My strengths and my statics, I wasn't too strong on. And I knew I needed to study dynamics, especially after doing practice questions. I knew I needed to study dynamics, but I knew, like when I was in school, I really liked fluids. I felt good in fluids. I felt good in heat transfer, measurements and controls, materials, properties, and processing. I felt good about that kind of stuff, but I really felt bad about the stuff I did like freshman, sophomore year. And then I wasn't too strong on thermo, but I knew they wouldn't ask anything too crazy to figure out. I thought I could study thermo. But the best way that I did to study, especially like thermo and stuff, you gotta use the equation sheet. The equation sheet is your friend. Like a lot of stuff, because I took thermo, I kind of, at my school, there were two different ways to take thermo. There was engineering thermodynamics and mechanical and aerospace engineering thermodynamics. It was during COVID time. My GPA already wasn't the best. I think at that point I was like at a 2.9 or a 2.8. I said I don't want to tank my GPA anymore and put myself in a bad position to secure an internship and take MAE thermodynamics and get like a C minus. So I just took regular engineering thermodynamics. It was taught by a MAE professor at my university, but I said, man, I'm not playing with it, bro. I said I just wanted to get an A, help boost my GPA, let all the other students get the low grade. And I felt like I got a good thermodynamics understanding, but I knew, like, considering the circumstances, it wasn't as strong. Also considering it was COVID, so I knew I wanted to study thermo. When I did my materials processing and properties question, like you just got when you start to study, you realize they're never gonna ask you anything crazy. I knew I was strong in heat transfer, but I knew they weren't gonna ask me to find the overall heat transfer from a fin array. Anything too crazy without giving me all the properties I needed from the formula. Like they would have gave me the Nusselt number. They would have gave me the thermal conductivity. It would have gave me those variables. And so for studying, the thing that impacted me the most studying, because I wasn't the best in statics and my dynamics, because I felt like when you get higher and higher in your engineering coursework, you start to make more and more assumptions. And once you see problems, you make assumptions, and then eventually, I felt like my forces acting on directions, it would begin to degrade over time because when I took vibration analysis, we made a lot of assumptions. I took MIMS, that's micro electromechanical systems. I took that class. We made a lot of assumptions on forces, and then I go back to do dynamics, and I'm like, oh crap. Even though we're only caring about motion, and like you use statics, I'm like, okay, even though we're only caring about motion in the x direction, there's going to be a resultant force in the x and y direction, and we have to care about that whole force. So a lot of times, those assumptions, they can come back to bite you in studying. But yeah, so if I get back to my personal study plan, I did Prep FE 4 months. And so doing Prep FE 4 months, I can tell you, I took the exam May 10th. If I'm honest with you, I really started pumping on them exams. Let me look. April, really April 28th. From April 28th to May 10th. No, May 9th. That's when, or really May 7th, because I didn't really do too many. I think by May 7th I was done with Prep FE. But from April 29th to May 7th, I was really pumping on them exams, pumping on them practice exams. And that's the best way. Prep FE is pretty good because they give you, I think, 3 exam options. You can do a categorical exam, so you can do an exam focusing on statics, an exam focusing on dynamics, and they provide solutions. Or you can do a timed exam, which is you give 60 minutes. I think they give you 20 questions, and you have 60 minutes to answer 20 questions. And as you go, you can flag questions for review. It's the timed exam is like the best representation of the real FE. And then you can get like a 25 question random exam, 75 questions. 75 minutes, 25 questions. And as you go through the exam, they'll reveal the solutions. I think the best thing that I did really was I did the practice exam, the categorical practice exam, and I really just focused on all on the categories I knew I was bad in, like statics and dynamics. I know I needed to review those, so I did as many practice exams as I could until I could get 3 out of 5 questions. Once I could get 3 out of 5, I'd move to the next subject. So like before I took the exam, I'll lay it out for you. So for Prep FE, I had 70% mathematics, 90% probability and statistics, 83% ethics, 60% econ, 60% electricity, 80% statics, 80% dynamics, 40% mechanics of materials, 60% material properties and processing, 70% fluid mech, 60% thermal, 70% heat transfer, 60% measurements, and 90% mechanical design and analysis. And I was like, at that point, I just wanted at least 60%. I knew that mechanics of materials only got 40%. I did not care at that point because I said, I'm at 80%. I'm at like dang near 100% in heat transfer. I know my measurements. I know my fluids. If I don't get all my mechanics questions right, I'm going to sleep easy. So that's kind of how I felt about that. I did the test booklet. And the thing is, I read on Reddit that some person, they got 2 test booklets, and a lot of the questions from the 2 test booklets were like similar. So, I think, so what I was doing at first is I was going through the test booklet and I would do questions until I missed one. Because I bought the test booklet like my junior year summer. And I would do questions until I missed one. So maybe I would do 3 questions, miss one, be done for the day. Do 4 questions, miss one, be done for the day. Maybe miss the first one. I think I got up to 25 questions. And then once I got my job, I was like, oh, I'm not gonna take the FE. I don't care anymore. I already got my job. But then, near graduation, I was like, well, I might as well take it. It doesn't hurt because it's gonna be harder to study on the back end. So I started studying again, and I went back through those questions when my practice test. I did 2 practice tests. Did 50 questions on the first one, 50 on the second, and I gave myself about 250 minutes for each section. No, 150. My bad. 150 minutes for each section, and that was all the time I needed. And I think I got like, if I'm honest, I don't have the piece of paper with me, but I think I got 50. Yeah, I got 55% overall when I did my full exam analysis on the practice exam, and I was like, well, that's barely passing. But eventually, as I'll probably say a lot during this, there comes a point where you either know it or you don't. Like there's gonna come a point in studying where you know it or you don't. You're either gonna hit the point where you're gonna be able to solve the question easily, and like you know what to do, you know what to look for, you know how to do the search function and look in the exam booklet to know what you're looking for, or you don't know it. Like a lot of the dynamics questions, you're gonna need to know the coefficient of kinetic friction, coefficient of static friction. You're gonna need to know if is this a statics question? Do I need to know belt friction? Stuff like that. You need to know conservation of momentum, conservation of motion. You need to know those type of things. And if you can look at a question, you know what to look for, you'll be fine. That's what happened to me. As I was studying for the exam, which will be for a lot of y'all, if you're thinking about taking it, you should know you may be a little discouraged because you may not be the best student. Like me, I wasn't the best student. While you study, you're going to be like, okay, when I hit a dynamics question, I probably need to know potential energy, kinetic energy, and U, whatever, I forgot what U means. But you need to know potential, kinetic, and you need to know U. So you need to know TV and U. And if you can, and you can look up the formula in the equation sheet, in the formula sheet, and you'll be able to be like, okay, this is applicable or this is applicable. The other thing in the equation sheet, which is good, is even if you scroll through and read, there will be like separate sections that are specific for what you're looking for. So there may be a section that says um for specifically for rotational motion, or for specifically for angular motion, or specific for isothermal heat transfer or isentropic fluid flow. So you may be able to read the question and then figure out what type of scenario, what type of system is this, and then you'll be able to get an answer. Um, so for the time during exam, so to be honest, don't worry too much about your time during exam. As I said, you either know it or you don't. And when I was saying all that stuff about the questions and practicing and stuff like that, you'll get to the point like me. When I was studying, I didn't study prep FE too much the 2 days before the exam because I felt like, hey, I've done so much studying, so much preparing. It's going to really boil down to what questions I get on the exam. I knew if I got a trust question or a find the zero force member in this trust, I knew that I could give it my best shot. I may not get it correct, but I was going to do decent. And then I knew if I got a lot of fluid mechanics and heat transfer and measurements questions, I'd knock it out the park. And so, eventually you're going to hit that point as well. You're going to know your strengths, you're going to know your weaknesses. Now, one thing I will say is make sure that you know your strengths. Like heat transfer, I knew my heat transfer. I knew my fluid mech. And eventually I knew most of my thermal. I knew my materials. I knew my mechanical design. I knew my mechanic. Like the stuff you know, make sure you knock it out the park. Now I will say this. I thought I knew my mathematics. And this goes back into the exam. I know you open up the exam, it's mathematics questions. My mathematics questions were hard. Like the first couple, they were difficult. And then I had some questions. Like one of them was like an algorithm question, and I had to just flag it and come back. But the thing about flagging and coming back, make sure you click an answer when you flag it. Like click an answer, like guess, flag, and come back. Because when you are submitting a section, you're able to review all your flag questions. And don't worry, they're going to be like, are you sure you want to submit this section? Are you double sure? Are you triply sure? You're not going to be able to come back. So don't worry. You're going to be able to flag, get to halfway through the exam. They're going to say, all right, here are all the questions you've answered. Here are the ones you flagged. Here are the ones you didn't flag. And you're going to be able to review that. But time during exam, don't worry too much about it. Personally, I wish I had more time because I felt like I would have got 100 if I had more time on the exam. But I didn't have as much time on the exam as I anticipated. So like there are some things I wasn't able to completely get. There are some things I was able to completely get. But I wish I had more time on the exam so I could get those questions correct. So here are some miscellaneous tips that I had. So make sure to arrive to the exam site early. When you get to the exam site, it's all going to be, Pearson based. Make sure you get to the exam site early and give yourself enough time to get acclimated. I think I took mine at 8 a.m. I know there's a later slot. A lot of people suggest a later slot. Looking back on things, I'm not too sure if I would have preferred the later slot or the slot I took. The later slot is good because it gives you time to relax during the day, maybe review. But the early slot, I took mine at 8 a.m. And so, I woke up, went there, had a granola bar, took the exam. Make sure to hydrate before the exam and eat enough to perform well. I know I personally perform at my best when I'm like a little hungry. So I made sure I was a little hungry on the back end. And that's how I was able to perform well. Make sure to hydrate. You can take bathroom breaks, but make sure you use your breaks wisely because you get one allotted break halfway through the exam, but then after, like, when you're not using that break, it takes time away from your exam. Have a good calculator and make sure you're able to use that calculator. You can review the NCEES website to double check which calculators are allowed, what's not allowed. I use the TI-30XS. It does. You can't do integrals or derivatives or stuff like that with it. But if you're getting a question that complex on your, like if you're getting a non-homogeneous second order differential equation, just skip it, bro. Just skip it, or just skip it and come back. That's all you got to really concern yourself. Just skip it and come back. Because questions like that, they're not asking you to really solve it. But no, they are asking you to solve it. You may have to use this equation sheet, but me, I wouldn't answer it, bro. I wouldn't be dealing with it. But if you have time, start using the calculator early in college. Like I know I took digital control, and I wasn't using my graphing calculator because I was preparing for the FE, and I was using my TI-30, and there was a question about, it was like, I forget what type of, no, we were doing, oh, I forget what it's called. I know how to do it. Differencing equations. We were solving a differencing equation, and I wished I had my graphing calculator because I couldn't do the math fast enough on my TI-30. So I was just like, you know what? I'm gonna just hold the L on this, and I had to hold the L. But make sure you use your TI-30, the whatever calculator you're allowed to use, so you can get practice with the format and prepare. So when you get to the exam, the calculator isn't too foreign to you, because you're not able to use graphing calculators. But since y'all are on this video, y'all probably already knew that. And as I said before, make sure to perform well on your strengths and study to improve your weaknesses. Know what your strengths are, know your weaknesses are, and know like your worst case scenario exam. Like I knew going into it, my worst case scenario exam was if I got like few ethics questions, like 4 ethics, 4 probability, 6 maths, and like got 14 statics, 15 dynamics, and 14 mechanics. But like it really boils down to trying to get 3 out of 5 on every question. Trying to get out of every 5 questions, get 3 of them right. That's what it really boils down to, and I think that all of y'all can do it. Now, the overall tips is if you practice enough, you will be okay. That's what I'll say. If you study for a week, 2 weeks, if you diligently study and you are diligently learning, you'll be okay. If you study for a week, maybe 2 weeks, you'll be all right. Study. The longer you study, the better you'll be. Don't study, in my opinion, because this is just personal opinion. This may not be true for everyone else, but if you study for like, if I knew if I studied like 3 months ahead, some of the stuff I'd be foggy on as the exam got closer, and the cram studying on an exam like this was necessary for me. But be confident and choose the best case answer for the scenario. None of the answers are gonna be unrealistic. There's never gonna be a question like somebody's throwing a baseball from a height of 100 feet and the ball goes 900 miles. How fast did they throw how much velocity did they throw the ball with? You're not gonna get a question like that. All your questions are gonna have realistic answers. Well, I guess I should say if somebody throws a ball from a feet at 100 100 feet, and they're throwing it at like X velocity, you know what I'm saying. You get what I'm saying. Like if they say they throw a ball from 100 feet and the ball goes 85 feet with crosswinds of 4 miles per hour, how far would a ball go? They're not gonna. How fast did they throw the ball? Nobody's gonna throw the ball like 120 miles an hour. There's probably gonna be something that says, oh, maybe they threw it 60, maybe they threw it 30. There's gonna probably be like something that says 10. There's probably gonna be something that says 25, and you're like, okay, maybe it's between 25 or 30 if the ball went that far, and you can kind of engineer an answer, maybe use a formula to get an answer that's realistic. And also you can engineer an answer via answer choices. I know a lot of the stuff like I studied my thermo and I was strong in it, but then I got a couple stoichiometric questions. I only really saw stoichiometric questions when I took industrial energy analysis, and I was like, bro, this isn't even mechanical engineering. It is mechanical engineering. I know that. But I was like, I'm never going to see this. If I need this answer, I'm going to hire a chemical engineer. But I sure got it, bro. I sure got I got two, maybe even three stoichiometric questions. And I laughed. And I just said, hey, maybe it's probably not the most obvious answer. So I went with the answer that's a little less obvious, and it was correct. I hope it was correct. I passed, so it doesn't really matter. But you can engineer an answer via the answer choices. A lot of times, if you feel like the question is easy, then it's probably an obvious answer. If you feel like the question is not easy, based on the way it reads, it's probably like the not obvious answer. If that's any tips, but there's other videos and you can go to Reddit. There are some tips on test taking, and I'll go into my personal theory a little bit. And this is all headcanon. This is all just what I think. But I think when they write the exam, now here I'll go common theory first. So this is common theory. The common theory and the agreed upon theory is you need to get 50% of the scored questions right. There's 110 questions. Only 100 of them are scored and 10 of them are unscored. If you get 50% of the scored questions correct, you will pass. That's common theory. And that's why people say, hey, that's why you get a little nervous while you're taking practice, because if you get 50% correct on the exam, and then of those 55 questions you got correct, 10 of them were unscored questions, you really got 45 out of 100, which isn't passing, according to common theory. So that's why people suggest, A, get 55% of the questions correct, get 60%, and you really know you passed. So my personal theory, this is personal. This isn't true by any means, but this is just how I felt after I took the exam. And when I took the exam, when I left the exam, I walked out the room, I felt like I passed. This is my theory. I think 30% of the exam is trivial. When you go in there, 30% is going to be easy. And this is just a side note. My electricity and magnetism, I think I did well, but it was a lot different than Prep FE. I will say that. Prep FE, a lot of their electricity and magnetism questions, you can just use the formula. But a lot of my electricity and magnetism questions on the exam, you had to do circuit analysis. That was probably just me specifically. Everything electricity and magnetism that you have to use a formula, or is like, what's the effect of a capacitor? And I got a capacitor question, which was like more of a definition-esque. There was like, how can you describe energy that's stored in a capacitor over time? And it's like, it's just energy stored decays over time. We know that, but it was just the best answer. There were two that were similar, but you just have to choose the one with better wording. That's same with ethics. Make sure you knock out all the ethics questions. The ethics questions, some of them you can say are tricky, but make sure you just choose the best answer. Like, do it as like an answer somebody would want to hear. There you go. Choose what you think somebody would want to hear. But to get back to it, I think 30% of the exam is trivial. And a lot of that triviality, I feel like, is in the ethics. You get a couple statistics, econ, electricity. But some of the trivial stuff is going to be in the core, like the statics, dynamics, mechanics of material, stuff like that. But 30% of the exam, I feel like, is trivial. 50% of the exam requires good engineering knowledge and studying. So that's like, the what formula to use for convective heat transfer. You know how to read how to read one of those material processing graphs. You know that. You know stuff like that. You know about motors and generators. You know about springs and bearings. You know about fluid statics, fluid dynamics. You know Reynolds number. You know coefficient of lift, coefficient of drag. You know stuff like that. And I was just saying that to make myself sound smart. I'm really not that smart. But I'm just saying, like, common engineering thing. You know what to look for if there's a question. Because that's what I read online too. Somebody said, the question isn't testing what you know. It's testing, given the equation sheet, could this individual get an answer that is reasonable within a quick amount of time. This is more in my theory. I think you got to ask yourself, what is the examiner looking for? I personally feel like they want licensed engineers because they licensed engineers are engineers that can get are like contracted, like maybe NASA's doing something. They need a contracted licensed engineer, someone that knows their stuff to review it. And if somebody's paying for a licensed engineer, they don't want them. They say, "Hey, can you review my bridge?" Like for a civil engineer, like, "Hey," or for a mechanical engineer, they're like, "Hey, can you review this new toaster? I got a new cool toaster. Can you review it for me?" They don't want to pay the mechanical engineer, let's say this is outlandish, maybe, I don't know, $68 an hour, and I don't want the person to work for 8 weeks to figure out if it's a good design. They want to say, "Hey, I'm going to pay you this much. I want a good analysis, and I want it quickly." That's what a good engineer will do. They'll give you a good analysis. They'll give it to you quickly. That's what the licensing committee is trying to get. They're trying to get good engineers that can things that can give reasonable, justifiable answers quickly. That's why they say, "Hey, we're going to write this exam. We're going to give you an equation sheet. We're going to ask you things. Use the equation sheet to get a good, justifiable answer. If you don't know it, you don't know it. But you got to know most of your stuff to pass." That's what they're asking, I feel like. So I'm like, they're going to get like half of the exam. They're going to say, "Hey, we're going to throw in a couple key terms. If you know your stuff, you're going to be able to solve it. If you don't know your stuff, it's going to look foreign to you." And then 20% of the exam, I feel like is difficult and time consuming. Like how I complain about the stoichiometric. 20% of the exam, like in the algorithm question, it's going to be like maybe mathematics. Definitely, they're going to give you a mechanics of material. Make sure you know your torsion, your polar moment of inertia. That tripped me up. I didn't figure that stuff out like until 3 days before the exam where to look for those formulas. Make sure you know where to find those formulas. I don't have the equation sheet right in front of me. If you leave a comment, I'll definitely make a video or something or try to help out. You can always leave a comment. YN Papa John, you can send me an Xbox message. Um, this is just the best way I knew how to stream. I didn't want to include any PII information in the video, but so I just decided to stream from the Xbox, and it's easiest for me to upload it this way. But yeah, I feel like 20% of the exam is difficult and time consuming. It's gonna be like you're gonna get. Let me look. I have the. You're gonna get. I know for sure. You're gonna get like a pendulum question that's difficult, or maybe you're gonna get a theoretical question that's difficult, or like me. I knew this is like a difficult question to me. A rigid wheel with radius r rolls without slip against a horizontal surface, as shown in the figure. And trying to find the magnitude of trying to find the magnitude of total velocity at point A, which is different than the origin point for the rigid wheel. I said, bro, I said it'd take me forever to solve because I wasn't fluent in that. I feel like 20% of the exam is gonna be difficult to solve. I know specifically I got a question that was fluid flow and turbomachinery based. I never got a question like I studied, so I had to go. I think that question took about 8 minutes to solve, but it was. I put a guess and I came back, and I'm lucky I had enough time to come back and change it because I was able to figure out the right answer. But I feel like 20% of the exam is difficult. So to recap, 30% of the exam is trivial. 50% of the exam requires decent engineering knowledge, and 20% of the exam I feel like is difficult questions. And if you think about it, as long as you can get all of your stuff, because like it may give you something y equals mx plus c. I mean y equals mx. What's the slope? Or they may give you a second order differential equation and ask you to solve for the constant, or maybe a first order homogeneous differential equation for the constant. Easy. It's easy stuff. As long as you can get the stuff and you can get half the good engineering knowledge stuff, and that's back to like knowing your stuff. You can get your heat transfer. I feel like is an easy section, but maybe it's just easy to me. But if you get the heat transfer, you get the measurement or the fluids, if you know that kind of stuff, you'll be fine. You can get like one or two hard questions, you'll be okay, you know? But also, I think this gave me confidence in my exam. So, personally, I think if you maybe didn't the 50% on the scored questions right for the cutoff score, I think if you do well enough, and let's say you get 13 out of 15, you get, you know, 8 out of 10 thermo, and you just bomb it on the statics, the dynamics, the strengths. You don't do too well in the electricity. You don't do too well in the and you just like don't get the cutoff score because you don't do too well in the mechanical design. But you fluids, your heat transfer, your measurements and stuff like that. If you knock that out the park, I think that there is a little bit of an element to it where you're like, hey, you did so well on the thermal fluids heat transfer stuff. Somebody's gonna evaluate your exam. We're trying to get a good engineer when they take um, their PE exam. They're gonna probably take thermal and fluids, and they'll probably do well, and they'll probably do thermal fluid analysis because what does the NCEES not want? They don't want to fail everybody. Like it's easy. They could make the exam that is very difficult to pass and not pass everybody, and then you don't have a lot of EITs going around that know the basics. They want a lot of EITs. They want a lot of engineers out there getting experience and the core that they want them to pursue the PE so that, United States has a lot of good, strong, professional engineers with good background that you can have trust in to solve engineering problems. I feel like that's the core. And I feel like as long as you do your best and you know your stuff, you'll be fine. As I'll reiterate, the main goal, the exam isn't too difficult because they want people with good engineering knowledge to pass so they can go and get their PE license. And then go take the PE exam, and they want those people to really show they know their stuff to get them their PE license. And then, overall the goal is they want to see who knows their good foundational knowledge so they can get the PE. But that was kind of long-winded. Um, Anything else? I don't feel like I have anything else to really say. I feel like y'all all can do it. To kind of recap, make sure to do Prep FE. The longer you can do it, the better. Prep FE is easy, good questions. Get the practice exam. One more thing to say. If you're not too confident, like I wasn't confident at first, I'll say you can look at the exam windows. I think there's 4 exam windows, maybe 5, 3 times per year, but once per exam window. Make sure to review the exam windows, and maybe you can get an exam that's like. So I knew if I didn't pass in May, I would take the exam again like the week of July 4th, and I would have studied from May to July, and I would have taken it late in the May exam window, but early in the July exam window. And so don't stress about it too much. Worst case scenario is if you don't pass, you'll just take it again and you'll pass the next time. And don't stress about it too much. The other thing I'll say is this. Please, 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 be confident, but don't study too much because eventually you're gonna hit the point where it's gonna really like while I was taking the exam, I realized, hey, no matter what I do, it's gonna boil down to what questions I get on the next exam and what questions I get on the next exam. And that's like not a great way to look at it because if you study enough, you'll know your stuff, you'll pass. But if you don't, like if you can get unlucky, that's all I'll say. That's what I mean to say. You can get unlucky. Like for example, I can get my statics questions and they can all be frames and truss questions and I'm doing questions where there maybe be 2 force members and I'm not even recognizing it. And then I can get 14 of those. And then I can get 14 mechanics of materials questions. And they're all Like I'm pretty good at the Moore circle though, but they're like just all stuff I don't really know. You just get questions you all are just like not strong at. Like if I got all thermodynamics, stoichiometric questions, and I'm just sick, I'm just disgusted. You know, you can get stuff like that, and you can just get all theoretical questions that are just very difficult. But I just want to leave you on a high note. Like you can do it. It's not too hard. They're not trying to fail. See, they're not trying to fail you. It's not like school. Some of your school class, like I know me personally, some of my school classes, like that thermodynamics, the MAE thermo, the teacher, that's where they weed people out. They're not trying to weed people out here. They're trying to weed people in because they want people to pursue the PE. They want to say, okay, they know the basics. They're good enough to get their EIT. Hopefully, they'll pursue the PE. Um, and if you've been out of school for a while, because I took the exam like right before I graduated, but if you've been out of school for a while, my best suggestion to kind of review, you can do a review course. I don't know which are really good, but after hearing what I said, I'm not the best student. In my last year of class, I took economics, which it gave me basic engineering economics knowledge. I took heat transfer. I took materials, writing intensive. Um, I don't even really. I took industrial energy analysis, and I took MEMS. Then I took vibration analysis, capstone, digital control, thermofluids lab, and energy technology sustainability. Those are the classes I took in my last year, and a lot of a lot of that did have some bits and pieces of thermal, bits and pieces of control. Well, a lot of controls, but bits and pieces of heat transfer, bits and pieces of material processing and mechanical design and analysis. But if you've been out of school for a while, my best suggestion is definitely if I was gonna try to give you your plan to succeed, I would do prep FE and do prep FE until you could knock down the statics and dynamics and mechanics. I feel like the best way to learn those is to do practice questions. When you get to the thermo, you can you can do some prep FE thermo questions, but a lot of the stuff you may have to do some reviews, so maybe some YouTube lectures. If you can go through a textbook, I don't have any textbook suggestions, but like some YouTube lectures may be good if there's some online courses. The fluid mechanics, yeah, do some online courses for fluid and thermo. If you know convective and conductive heat transfer and you know your heat exchangers, just do practice questions around conductive heat transfer, convective heat transfer, and heat exchangers. Radiation, radiative heat transfer isn't difficult, especially as it pertains to the exam, because they're not going to ask you to calculate anything. Like there was some shape factors questions on my exam, but I don't want to brag, but I know my shape factors. So, but if you're not too strong and stuff like that, I say review is good. But if you've been out for a while, then maybe I would suggest doing prep FE for about 3 to 6 months, and then doing a practice exam. Definitely do prep FE because it'll help you learn the equation sheet, and then be like you know the theory of the mathematics and the theory of the physics, but you also really need to understand the equation sheet. And the theory of the mathematics and the physics, it'll lay the background for you to know the equation sheet. And when you see a question on the exam, you know where to look. But to be honest, if you do enough practice questions, things may begin to look familiar. So if you maybe you've been out of school for about 8, 9 years, and you're trying to take the FE, or maybe you didn't go to ABET school and you've been working and you're trying to take the FE, I would definitely suggest if you can afford it, I'm doing prep FE. I forget FE was like $30 for a month, but like for $30 or $45 you can get like 60. I mean 6 months. Maybe it was 50 for 6 months. Maybe it's 50 for a year. I don't know. But try to do the most affordable thing. Try to get the year long and practice for a year. and maybe try to get two tests. I mean, practice tests. I didn't do the Lindbergh, um, and I don't know if I would suggest it. I would definitely suggest Prep FE, and I would definitely suggest doing the practice questions. And also, if you can't really afford the Prep FE or the practice book, you can download the equation sheet. And if you're just gonna study based off the equation sheet before the exam, and you don't have any like coursework to refer to, then I would suggest to like really go line by line of the. I would suggest every section if you've got the time, but if you're in a rush, like maybe your job is like, hey, we're looking for people to get their EIT, and you've been out of school for a while. I hope this isn't your situation, but if you just got to take the EIT and you've been out of school for a while, and you don't want to do Prep FE, and you don't want to get the practice exam, you just kind of want to take it because you're that confident, then do the equation sheet. Make sure you have a good calculator. Definitely review every line of the equation sheet from statics to mechanical design and analysis. Like every section, you got to review statics to mechanical design and analysis, bro. Every line, you got to know where it's at, and you got to understand the equations. If you can understand the equations, you've got a good knowledge. And then, they can't give you an engineering question without having words, and then having the words will give you key factors of what to look for. I know I've been rambling. I said I was a little long-winded, but I think that's everything I wanted to discuss. But y'all can do it. I believe in y'all. If you have any questions, please, please feel free to leave a comment. I hope this helped somebody out a little bit. I hope you're listening at 1x, 2x speed, but all the best, man. Godspeed.